Today we are going to solve some questions, top questions on Chemical and Ionic Equilibrium chapter as you guys have asked. Let's get started with the first question. The degree of hydrolysis of salt of weak acid and weak base in its 0.1 molar solution is found to be 50%. If the molarity of the solution is 0.2 molar, the percentage hydrolysis of the salt should be. Okay, so here we are going to solve 10 to 15 questions. The remaining questions I am attaching as a PDF. You can download and solve it yourself. The answer is also attached. Okay, so let's solve this question. First, understand the concept for a salt of weak acid and weak base. Right, here we have salt of weak acid and weak base. So the degree of hydrolysis H will be root of Kw by Ka into Kb. Right, H is independent of the concentration of salts of weak acid and weak base. Right, so let's apply the concept. First of all, 0.1 molar solution is found to be 50%. Right, so 0.1 molar H will become 50%, so which is 0.5 for 0.1 molar concentration. H is equal to how much for 0.2 molar concentration that we have to find. That is the overall question. So, since H is independent of concentration of this type of salt, then that would be same, right? So, if that it can be 0.2, it can be 0.3 or 0.4, whatever the concentration it can be, H will be the same. So, H will be 50% again. Associates as like this. If observed pressure at equilibrium is 2280 torr at 380 Kelvin, what is that Kp? Okay, they have given the equation also. So just PNH3, that is equal to our P pressure of H2S. So that they have mentioned it as these two are gases and this is solid. So what we can observe is that solid is decomposing into two gases, right? So which means that will be forming a equimolar solution, equimolar gases. So P by 2, that would be our pressure of H2S or pressure of ammonia. Right, so P stands for total pressure, correct. Now, let's find out P total. P total is given as 2280 torr divided by 760 to get it as an ATM. Okay, so ATM which will comes out to be 3 ATM. So what about the ammonia partial pressure? So PNH3, or if you're taking for a hydrogen sulfide also, that would be 3 by 2, 1.5. Okay, so that is ammonia or H2S partial pressure. Now let's calculate Kp. So Kp, that is equal to, we are taking only ammonia and H2S because those two are only in the gaseous state. Okay, so 1.5 into 1.5, that is equal to 2.25. Calcium carbonate in 0.64 liter container at 1000 Kelvin. For calcium carbonate goes as calcium oxide plus CO2, Kp is given, and calculate the mass of calcium oxide at equilibrium. Okay, so the reaction is also given. Let's calculate the moles of CO2. So for calculating moles of CO2, just use the ideal gas equation. PV is equal to nRT. So N of CO2, that is equal to PV by RT. So pressure, that is 0.04 because Kp is given as 4 into 10 to the power minus 2, and volume is 0.64 liters divided by R value is 0.082 and T 1000 Kelvin. So upon solving this, you will get the number of moles of carbon dioxide, that is 3.12 into 10 to the power minus 4 moles. What they are asking, mass of calcium oxide. So for that, look at the stoichiometry ratio. CO2 to calcium oxide, that is in 1:1 ratio, right? So 1 mole of CO2 formed, that is equal to 1 mole of calcium oxide formed. So number of moles of calcium oxide, that is also equal to 3.12 into 10 to the power minus 4. But they are asking for mass. Convert this to mass. What is the molecular weight of calcium oxide? That is, for calcium that is 40, oxygen that is 16, so that will be 56. So 3.12 into 10 to the power minus 4 into 56, that will give you 0.01747 grams, but they are asking it in milligrams. So the answer becomes 17.92 milligrams. Okay. 100 ml of 0.1 molar weak base titrated with 0.1 molar HCl. pH at 50 ml and 100 ml are. First 50 ml of HCl. pH is 50 ml and 100 ml are. Let's calculate for 50 ml. So what is happening over there is weak base, let's say BOH, treated with HCl gives BCl plus H2O, right? So B plus, that is equal to concentration of BOH, right? Now POH, that is equal to PKB, so minus log of 2 into 10 to the power minus 5, because that is the KB value given. To solve it, 5 minus 0.3, which is 4.7. So POH, that is 4.7. What about pH? So pH will be equal to 9.3, right? So number of moles of HCl will be, moles of HCl will be equal to 100 into 0.1. Convert that to liters, because taken as 100 ml. So convert that to liters, you will be getting 0.01 moles. So volume 100 ml HCl plus 100 ml of weak base. So totally 200 ml of volume. So 0.1 mole is the number of moles of HCl and the volume is 200 ml now. So what about the concentration? Now that will become, the overall concentration will become 0.05 molar. Let's substitute it in the formula. pH is equal to half pKw minus pKb minus log C, right? So we know half pKw, that is 14, and pKb value we found, that is 4.7, and log C, that is log into 0.05, right? So 0.05 log, that is 1.3. So substitute the values, 14 minus 4.7 plus 1.3. So pH will comes out to be 5.3 here. So for 100 ml, that is 9.3, and for 50 ml, that is 9.3, 100 ml, that is 5.3. 50 ml of 0.2 molar acid, Ka value is given, mixed with 50 ml of 0.2 molar KOH, strong base, at 25 degrees Celsius. Now we have to find the pH. So let's calculate the moles of acid. So which will equal to 50 ml, no? So 50 into 0.2 molar divided by 1000, which will be 0.1 mole. Similarly for KOH, number of moles of KOH, that is again 50 ml of 0.2 molar divided by 1000, that is also 0.1 molar, 0.01 mole. So after neutralization, HA plus KOH, which will form Ka with H2O. So only we have salt and water. Let's calculate the salt concentration. How much salt will be formed? 50 ml plus 50 ml, total 100 ml. Volume is 100 ml now. So calculate the concentration of salt. That is, convert the volume to liters, 0.01 divided by 0.1, be equal to 0.1 molar. Now substitute it in the formula. pH is equal to half pKw plus pKa plus log C, right? So pKw, that is 14, plus pKa value is given as 1 into 10 to the power minus 5, that is Ka. So pKa becomes 5 now, right? And log C, concentration of salt, that is 0.1. So log 0.1 So pH value will comes out to be 9. So 9 is your answer. So similarly, you can solve this question also. 100 ml of 0.1 molar HCl is titrated with NaOH. pH after adding 50 ml, 100 ml and 150 ml. First you have to find the equivalents. After adding 50 ml of NaOH, first we have to find the HCl initially and do it for 100 ml and 150 ml also. Let me know in the answer in the comment section. The acetate acetic acid buffer is suitable in pH range of. Okay, this type of question we can expect. So what is the suitable range of pH of the buffer? So first of all, calculate the pKa of acetic acid. So they have given Kb value of acetate, right, which is 10 to the power minus 9. So pKb, that is equal to 9, correct? pKb, that is equal to 9. So what about pKa? So pKa will be 14 minus pKb. So that is 14 minus 9. pKa will be 5. Now, to determine the buffer range, the pH is equal to pKa plus or minus 1. That is the general formula. So the buffer range, pKa is 5, so plus or minus 1, which is 4 to 6. That makes your answer. Which buffer maintains pH is equal to 6? Choose. First one, I have HA at 0.1 molar and NaA 1 molar. Kb value is given as 10 to the power minus 9. Well, all you need to do is just remember the Henderson-Hasselbalch equation. pH, that is equal to pKa plus log of salt by acid. Okay, so let's substitute the first one. I have Kb value as 10 to the power minus 9. So pKb will be 9, right? If pKb is 9, then pKa will be 5, right? So 5 plus log of salt is 1 molar divided by acid is 0.1. So which will give you the pH as 6. Then what about the next one? Again, here they have given Kb of B minus, that is 10 to the power minus 10, which makes pKb as 10. So pKa will be 4. So for the second one, pH will be 4 plus log of salt is 1 by 0.01, that is equal to 6 again. What about C? Again, pH is equal to 10 to the power 6 is given. So 14 minus 6. 14 minus 6 is 8. So 8 plus log of 0.01 by 1, that is equal to 6 again. So any of the above or all of the above would be your answer. Molar solubility of AS2S3 in 0.3 molar of aluminum sulfide solution in terms of solubility product. KSP of arsenic sulfide is. Okay, so first of all, how that will get dissociate? AS2, S3 will get dissociate as 2AS3 plus plus 3S2 minus. Similarly, aluminum sulfide will also get dissociate as the same. Instead of AS, 2 aluminum 3 plus will be formed. So here the concentration of AS3 plus will be 2S, right? For a sulfide, S2 minus will be 3S, correct? So the KSP equation will be 2S square, 3S square, not square, it will be cube, yeah, cube. So which will be 4S2 into 27S3, that is 108S5, right? So now we have to find the sulfide concentration, which is common for both. From aluminum sulfide, we know that that is 0.3 molar concentration. So S2 minus will be 3 into 0.3 molar, right? So which will be 0.9 molar. Now substitute it in the equation where you will get KSP 2 is square, 3 is cube. I have, for sulfide, I have 3s cube value, that is 3s value, that is 0.9. And this one will be 4s square into 0.9 cube, which will comes out to be 2.916 s square, right? So that is KSP. Check out the options. Here we have, okay, so if I want S, then that would be S square is KSP by 2.196 and S will be square root of KSP by 2.196. So this must be your answer. It's supposed to be square root. Okay. And next one, pH of 1 molar benzoic acid and 1 molar sodium benzoate mixture is 4.5. Volume of the acid needed to prepare 300 ml of buffer. Okay. So first of all, pH that is given as 4.5 and pKa is given as 4.2. What you can do is substitute the values. pH is equal to pKa plus log of salt by acid. So, which will be pH 4.5, pKa 4.20 plus log of salt by acid. Upon solving this will go on another side, then 0.3. So, taking log, salt by acid concentration will be 10 to the power, taking antilog to that will be 10 to the power 0.3. So, which is approximately 2. Okay. Now, we have to find the volume of acid needed for 300 ml buffer. So, what we can do? Let's say the volume of acid is Va and volume of salt is Vs. And the concentration is 1 molar each. Right. So, since the molarity is same for both of them, what I can take is Vs salt by acid volume is also 2. Okay. Now, total volume that is 300 ml, right? So, Va plus Vs that is equal to 300 ml. From here, what I can find is Vs is equal to 2Va, right? So, Va plus 2Va that is equal to 300. 3Va is equal to 300. Va is equal to 100, right? So, the volume of the acid needed that is 100 ml. Clear? Metal sulfide precipitates first when H2S is added. Okay. So the salt with the smaller KSP will get precipitate first. Right? So compare the KSP values. Here I have cadmium sulfide 8 into 10 to the power minus 27. Zinc sulfide 1 into 10 to the power minus 21. And for H2S that is 1 into 10 to the power minus 21. So cadmium sulfide is less soluble, so it gets precipitates first, as you can see over here. So always remember lower KSP that will lead to lower solubility. Lower solubility means higher the precipitation. So that will get precipitates first. Then next one, in saturated H2S, what H plus concentration needed to precipitate cadmium sulfate but not zinc sulfate if cadmium 2 plus concentration is equal to zinc 2 plus concentration, that is 0.1 molar. Okay. So let's calculate for cadmium sulfate first. Let's calculate the S2 minus value. So KSP of cadmium sulfate, that is cadmium 2 plus S2 minus. They have given cadmium concentration is 0.1 molar. So 0.1 molar, KSP value is 8 into 10 to the power minus 27 into S2 minus. It will be 8 into 10 to the power minus 26. Correct? Similarly calculated for zinc. So zinc you will get again the same thing. Zinc concentration is 0.1 and the KSP is given as 1 into 10 to the power minus 21. So which will be zinc sulfide 2 minus concentration, that is 1 into 10 to the power minus 20. right? So 1 into 10 to the power minus 20. Then find the H plus concentration, because we are going to we have saturated solution of hydrogen sulfide, and what H plus concentration we have to add. So what you can do is, for H2S, Ka will be H plus and S2 minus divided by concentration of H2S, right? So the Ka value of H2S is given as 1 into 10 to the power minus 21. So 1 into 10 to the power of minus 21 equal to H plus into S2 minus, and the concentration of H plus is given as 0.1 molar. 0.1 molar. Sulfide want to precipitate means S2 minus concentration must be greater than or equal to 8 into 10 to the power minus 26, because I want that to be precipitated. So while substitute the values, 1 into 10 to the power minus 21 equal to, or you can also do one thing, take H plus on the one side, H plus square, and then it will become minus 21 into 0.1 divided by S2 minus. So the S2 minus, which is nothing but our 8 into 10 to the power minus 26. So upon solving, you will get H plus value as 1.12 into 10 to the power minus 2 molar. Similarly, if for Zn is not to precipitate means S2 minus value must be less than 1 into 10 to the power minus 20, right? So in the same equation, I'm going to substitute it for zinc sulfide. So 1 into 10 to the power minus 21 into 0.1 divided by 1 into 10 to the power minus 20. So where I will get 1 into 10 to the power minus 4. So the H plus concentration, that will be 0.01 molar. So the answer must be greater than 0.01 molar. When ZnS starts precipitating, cadmium 2 plus lift is. It's a continuation kind of question to the previous one. When zinc sulfide start precipitating. So KSP of from there we already calculated the sulfide value. So which is, for zinc sulfide we already know S2 minus, that is equal to 1 into 10 to the power minus 20. Okay, so to calculate cadmium 2 plus, how much that would be? So the KSP of cadmium sulfate, that is cadmium 2 plus and S2 minus. So this is 8 into 10 to the power minus 27, and sulfide, that is 1 into 10 to the power minus 20. Now cadmium 2 plus concentration would be 8 into 10 to the power minus 7 molar. 100 ml of hard water sample divided into two parts. Part 1 is, I have 40 ml of 10 to the power minus 3 molar EDTA solution, and part 2 is 103 ml of calcium hydroxide is also added, and this many grams of calcium carbonate is precipitated. Okay, so find the temporary hardness in ppm. That is the question. So question may look so difficult, but it is not, because they have given the mass of calcium carbonate, and the precipitation is depend on carbonate and bicarbonates only. Okay, so the precipitated calcium carbonate corresponds to the temporary hardness. So let's take the mass of calcium carbonate, that is 6 into 10 to the power minus 4 in 100 ml sample. So which will become, this is in grams, in 100 ml. So ml means just converted to milligrams. So that what will you get? 0.6 milligram in 100 ml. So how I can write it? 100 ml, convert that to liters. So that will be 6 milligram per liter, which is nothing but 6 ppm. This is an interesting question. Match weak acid HCA, Ka value is given, titration with NaOH. They have given the list of volumes added of a base and also mentioned that 100 ml of 0.1 molar HCA is titrated with 0.1 molar NaOH. Okay, so let's solve one by one. Before that, understand one thing. Here we are adding 0.1 molar NaOH and 0.1 molar HCA, where I have 100 ml of HCA. Okay, first 10 ml. 10 ml of NaOH. So the moles of NaOH added, that would be 10 ml of 0.1 molar. So which is 0.001 mole. HA concentration in the beginning I have 100 ml of 0.1 molar, that is 0.01. The HA concentration in the beginning, that was 0.01 moles. So after adding this much moles of NaOH, so remaining HA after neutralization, so remaining HA will be 0.009, right? Formed will be 0.001. Okay, so now substituted with the formula pH is equal to pKa plus log of A minus by HA concentration. So pH is equal to pKa plus log of 0.001, that is formed salt, and HA concentration, that is remaining 0.009. So that is nothing but 1 by 9. So which is pH is equal to pKa of 2 log 3. Right? So it matches with pKa 2 log 3, that is C. Sorry, yes. Similarly, you can find for 25 ml, 75 ml and 100 ml to match with the list 2. Okay. So let me know what else chapter you want to discuss in the next session. Thank you.